All right, here we go.
I'm gonna come in and
How long
try.
is that?
What?
Definitely.
3 problems.
Definitely helpful. I know what I'm back on.
Three. Okay, here's my goal today. I'm going to do 3 problems for you right now. They're going to look really close to your homework today. I'm going to give you kind of a range of problems. In fact, once I'm done, I'm going to see if I can leave them up on the board, and then you can get to work right away. You have 6 problems in your homework. It'll be one of your last assignments of the week, because what we're doing the rest of the week on Thursday, Friday, we're reviewing for the test that is next week.
When's the test?
So test is Monday, Tuesday next week.
You said you don't do tests on Mondays.
Well, it's going to be.
That's really hard on me.
Let's go.
All right, here we go. So, all right, here we go. First example, and goals today. I just want to do examples of the reciprocal functions. So here's our first one. We're going to do -5 cosecant 3/4 x. Okay, our goal is to graph this. Our goal is to graph. All right, once we get through these, then we're going to look at the other ones. All right. My goal is to each problem I'm going to give you is something that we may not have seen before with the reciprocals. Like on this one, I threw in a negative sign. We haven't seen that yet. The next one I'll throw in, when we do the secant graph, I'll throw in like a pi on the inside here. And maybe I'll throw a fraction on the outside. We haven't seen one of those. And then when we get to cotangent, I'll really mess with the numbers on that one, and we'll kind of move it all around. But that one should be fairly straightforward. Okay, let's kind of get through this. First step, when you do this problem, this is actually what you should do first. You should be drawing this. This is the first one you should be drawing. You actually have to draw the original sine function, and then once you have that, then the reciprocal can go off of it, the cosecant. So this is the graph I'm going to draw first. So when you do this, we're going to the right. We have 4 hash marks, and it looks like we're not shifting up or down, so it's going to be over the x-axis here. And then what's my peak and valley going to be from there? 5. So we're going to hit a peak of 5 and -5. Now, how I know that? The number out front is the amplitude number, because remember, this is the basic lettering that we've been using all week, especially all last week. This is the basic letters we've been using. A affects amplitude, B affects the period, C affects the shifting of your center line or the origin line, whatever I call it. Okay, so the A is affecting amplitude. That's my -5. So I'm going to hit a peak and valley of 5 and -5. Okay, now the 4th hash mark down the road. Typically, it's 2 pi. That's for cosine, sine, cosecant, secant. Usually it's 2 pi. The problem is I do have a number in front of my x. So the trick is you have to divide by it. So we're going to take 2 pi and we're going to divide by 3/4. Okay? All right, when you divide by 3/4, you have to flip this over and do a reciprocal. So this will actually be 2 pi times 4/3, which turns out to be 8 pi over 3. Okay, does that make sense on how I did the reciprocal when you divide by that weird fraction? Yeah. This thing right here is the same thing is if they were to write 3x over 4. That's the same thing. You're still dividing by the number that's in front of x, and it's still a 3/4. Even if, on your problem, which they don't have, if they did something like this, where they just had x over 4, that's a 1/4 x. That's the number out front. Yeah, there could be potentially one of those today.
Mr. Ward.
Okay, all right. But anyways, I found my 4th hash mark. So I cut that in half, which is 4 pi over 3. Cut that in half again, which is 2 pi over 3. And then you multiply that one by 3, which is just 2 pi. Because the 3 would go to the top, you'd get 6 pi, and divide by 3, which simplifies to be 2 pi. But again, divide by 2, multiply by 3, and that's how it simplifies. And I do require that you simplify those fractions today. Now, we're going to draw the sine function first, and then after that, we'll go after the cosecant. The sine graph usually starts in the origin line, goes up to its highest point, comes back to 0, goes to its lowest point, comes back to 0. That's what sine normally does. Now, why we needed that? Because anytime it comes back and hits the origin, this origin line, then you have an asymptote there. Because when we start drawing the reciprocals, you can't flip 0 over. That's why there's this undefined boundary. Now, if you don't want to draw the sine function, you don't have to. I think it's the easiest way to do this. That way you know where to start, you know where they go, you know where the asymptotes are gonna be. It's kind of important that you do put those in there. Now, the whole reason why I did the sign and I did these asymptotes is because this is my original problem.
Hey, Ward.
The cosecant's going off of it. Question, oh yeah, I gotta flip it upside down.
Yeah.
I gotta do that. Okay, all right. Any questions with the setup so far? Now, if you didn't hear me, and I was about to get a question here in a second. This is the normal sine graph. That's what normal sine does. Bless you. Okay. All right, but here's the difference. They have a negative sign out front, and I totally forgot about that. So we have to worry about the negative sign. So the only difference here is that it's just going to be flipped upside down. So here's the main difference. It'll be going down to its first point first, coming up, going to its highest point, and then coming back down. So this is the graph when there's a negative sign out front. It took the sine graph and just kind of flipped it over. But since we're doing cosecant, we just go off of the peaks and valleys here. So this is your cosecant graph of the negative 5 cosecant 3/4 x. Now that is upside down compared to what it normally is because they threw a negative sign, so it flips everything over. Questions? That's the type of problem that I would assign today. I wouldn't assign anything where you shift it right and left. I won't assign anything where they put negative signs on the inside. That's a different style of problem.
Mr. Ward, if we forget to flip it, will you count the points off?
If you forget to flip it over,
Yeah.
yeah.
Well, what if you forgot to flip it?
But I just did.
Take points
Oh,
off
you're the
yourself.
teacher.
Someone had to tell you.
But
Yeah, someone.
no, I didn't. I flipped it.
Mr. Ward,
that
someone
would've
needs
been
to
a-
take points off
So-
your grade right now.
All right. You can take points off.
Alright, fine.
All right. So moving on. Let's go to the next one. Next one is the secant graph. Okay, so the secant graph is let's go with like 1/8 secant, and let's go with 2 pi x. Okay, so 1/8 secant 2 pi x. So this is something we haven't seen for a while. So if we're going to be doing this, this is the secant graph. So what I have to draw first is I have to draw the cosine graph with all these numbers plugged in. And no, on this one I'm not flipping anything over, so it should be a normal graph. There's no negative signs. But anyways, on this particular problem I have to draw cosine, and once I have cosine, I've set up all my asymptotes, the undefined boundaries, then I can draw the secant graph. Okay? But I need to draw this one first. I always draw the original when I do sine and cosines. Alright, so if we draw the coordinate plane here, we're going to the right. We have 4 hash marks going across. We have a peak and valley. Now, where's my peak and valley going to be?
12.
What? 1/8. This is 1/8. This is 1/8. That is really, really, really small. Okay. If we were to put this on a normal graph, yeah, it's 1/8, so it's really compact. It is, if I was to draw the original graph, it shrunk so far that you wouldn't be able to tell the difference with the actual continuation of the flow of the graph. So that's why when I draw these, all my graphs kind of look the same. I just have the default lines I put. I'm just filling the numbers where they need to go. Okay, 4th hash mark down the road is normally 2 pi. That's the 4th marker. But we have to divide by the number in front of x, which is a 2 pi.
1.
So yeah, so when we divide, you are right. That is 1 and it's simplified. So then you cut it in half again, multiply that by 3. So here's my markers going across. Again, how I got those, whatever 2 pi is, that's my normal period, you divide by the number in front of x. Question?
Negative 1/8.
Okay, oh yeah, negative 1.
Oh, you have a straight line.
Alright, questions with the setup on the hash marks?
That's another point off this board.
Okay, another point, you can count up 2.
Oh, we're taking off 11.
Alright, here we go. Let's keep going here. The cosine graph starts at its highest peak, goes down to the first marker, goes to its lowest point, comes back up to the next marker, goes to its highest point. Alright, that's the normal cosine graph. Now, anytime it hits the origin line, we do have to fill in an asymptote in there. So on my particular problem, I do have an asymptote right here in the undefined boundary where I hit the origin line. I do have another one right here because you can't flip over 0. That's when it would hit zeros right there. And now from there, I can draw the secant graph. The secant graph is going off the cosine, but it's going the opposite direction. So it starts at the peaks and valleys and goes the other direction.
Holy cow.
Now, again, this is only one picture. I think one of the questions I had yesterday is like, will it continue over here? Yeah, it will continue over there and
Can you
go
draw
up.
that?
You can go up. Do you want me to draw?
Yes.
I need to have another half.
That's
over
called
here,
a parabola.
Over there. Actually, yeah, they would look like parabolas.
Yeah.
Yeah, you're right. All right. Okay, questions with the secant graph. And again, I only require one picture length. I don't require that you continue them. This is just one period length of it. If the book asks you for two, just ignore those directions like you always do. Just one picture length. You do not need to keep that green line for cosine in there. I always just leave it just because I like to see where I'm going. You don't need to. You do need to have all the numbers plugged in for the markers. You do need to have the asymptotes in there. So those dashed lines, okay? All right, questions? All right, last one today, we need to do cotangent. Remember, cotangent's very different. You don't need to go off the original tangent function to draw it. So that's why it's a little bit different. So I'm going to try to draw this on the board here. Okay? All right. Let's see if I can zoom in on this.
That was a good one.
All right. Okay. Let's draw the cotangent function. Now, on this one, I think I'm going to throw in some negatives because I don't think we did one of those yesterday. Negative
231.
cotangent 2 over 3x. Let's do something like that. I don't know if I did any with fractions yesterday. I didn't do one with a negative for sure.
This gonna make it look like
It's going to look like tangent, yeah, because it will be flipped over. But it's still shifted, so it's not centered over the origin still. So, all right. But again, on these, we don't need to draw the original tangent because they're not connected for the most part. So on this first one, it's going to go to the right. It's going to have 4 hash marks. Now normally, we would go out to pi, because that's how tangent and cotangent work. But we have to divide by the number in front of x, which is a 2/3. So if you do that, if you divide pi by 2/3, it's actually pi times 3 over 2, which is 3 pi over 2. So that's your marker going across. That's the 4th hash mark. We cut that in half, which is 3 pi over 4. We cut that in half again, 3 pi over 8. And then you multiply that one by 3, which is 9 pi over 8. All right, questions on the 4th hash, or the 4 hash marks going across? Because again, tangent and cotangent go to pi, but tangent's that weird one where it's balanced over the origin, where you go half and half. Cotangent doesn't.
Why aren't we taking it 2 pi divided by whatever?
Because tangent and cotangent don't go out to 2 pi. They repeat their pictures after 180 degrees, which is pi only. The other ones, secant, cosecant, and sine, cosine, use 2 pi's. This one doesn't. Tangent, cotangent, all good. Yep. All right. Peaks and valleys. We normally hit 1 and -1. We'll still hit that because they don't have a number up front. But here's the weird part. We have to flip my graph over. It has a negative sign. So normally cotangent would have asymptotes on the outside. Right? We have the asymptote here. We have the asymptote there. That's the undefined boundary. Cotangent normally does this. It comes up here, and again, I'm just going to draw this dashed line. It hits the first marker, goes through the 0, goes to the next marker, and then it goes down to negative infinity. Like, that's what cotangent normally looks like. But since we have a negative, we're basically just flipping it over. So everything will flip. So we're still going to hit the origin right here, but we're going to hit the first marker and this marker in the opposite spots. They flipped. So it actually kind of looks like tangent's graph, but we're not centered over the origin. We're not centered over the origin, and it's been shifted. So it does look like tangent when you throw a negative sign out front. The whole reason why is that it is a perfect reciprocal tangent, so there is some idea that the numbers are flipping, and it is shifted, so it's a co-function. So that's why cotangent and tangent look so similar in nature. It's not like the other ones where they're radically different. But this is kind of a weird one. These are the only 3 I'm assigning you today, these 3 types. Cotangent, secant, cosecant. You're going to have 2 of each, that's all you're going to have. Pretty straightforward. This is your last assignment of the week other than our practice guide, which is not due until next week. So Pretty straightforward. Question?
Did you figure out an application?
Yeah, and I didn't even think about it, it's common sense. Tangent is actually used to find slope. That's what it's used
Oh,
for.
yeah.
So, I'm
Why
like,
is
duh,
that
I should
common?
have thought about that. When they draw the tangent graph, tangent's drawn like this and it's drawn like that.
Right.
The numbers you actually have here, like this is, this is 1 and this is -1, right? Whatever the markers are. The tangent, this graph is actually representing all the slopes of a triangle. That's actually what it's doing. So when you pick like a 30-degree angle, right? On a triangle, 30 degrees. This line here is 30 degrees from the base. That's a certain slope of a line, right? Certain tilt. Well, what this graph is actually telling you, this number, so like this is pi over 4, this is 45 degrees, this is pi over 2, this is 90 degrees, right? 30 degrees is roughly about right here. This number that associates on the graph is actually the slope of that. That's what it's used for. It's the actual number, it's the actual slope, and it's actually used in calculus. It's like, what you're looking at there is the main application of calculus, of what the whole point of calculus is to find a rate of change, the actual slope of objects, like any lines, any curves. So tangent's graph is the slope of any of the angles going from -1 or -90 up to +90. This actually represents all the slopes in that case, which is actually incredible, because if you go to negative angles, the triangle would be drawn like this. And it would be a negative, it would be going down. So that's why the angles over here have negative numbers. I didn't even think about it, like once I typed it in Google, I was like, I'm a moron. Like it's like the most commonly used thing we use in calc. I just never associate it with the picture, because I'm so used to just going and calculating it right away with derivatives and stuff. That's what they teach. But if you had this picture, it just gives you the answer. You can guess what the decimal is for slope. It's like at 45 degrees, the slope is 1. It's perfect. It's a 1-to-1 line. It's just one of those things I didn't even think about. It's actually the main point of calculus. Should have known that. So
That's
some
all
of my
right.
professors said they'd be mad at me. All right. Anyways, let's go through.
Wait, I have a question.
No, but they knew that. Ooh, what?
So, when you have two angles and they equal 90 degrees, what's that called?
Complementary.
When they equal 180, what's it called?
Supplementary.
Supplementary.
All right. Homework today. It's 6 problems. Here we go.
I'm not sure this down.
Page 546. Numbers 30, 32, and I know I'm going to jump around a little bit. Go with it. Actually, I want you to do them in this order. I know it seems a little silly that I went back to 19 and 22. I want you to do the cosecants first, the secants, then the cotangents. I think that's the order I assigned them in. But cotangents are last. I think I went in the correct order that I assigned them, so I'll have to work real quick, but.
I
I
definitely did not. Where was
I
it?
have some water sitting right here on the desk.
Why would your book be on that desk?
I sat it there. Now I want to buy
That sounds like a personal problem to me.
Is that a no?
What?
Yeah, I went the right order. Okay. Question?
Can I see how to like ask if
So
it's
naturally,
easier?
what is the?
Not very long.
That's definitely how you're calling it.
When you put that in the basket and you came back.
Or if I find my